Another question I had is what you mentioned with respect to low, high, and bad corruptive values.
Yeah, yeah.
Can you elaborate a little bit on
Yes,
that?
sure. See, a typical 4 to 20 milliamp signal.
Mhm.
For process industry, there is a standard called NAMUR 43.
Okay.
I don't know how many of you are familiar with that. It's a good idea to purchase that standard and see what it is. And in short, what it defines is uh, the 4 to 20 range of analog input output operation applies to the signal that is working right from 4 milliamps to 20 milliamps. Now, the question is what happens if the current either exceeds that or goes on the lower side
Lower
of it.
side of that, yeah.
So, the question is how much does it go out and what does it mean?
Yeah, right.
So, the NAMUR standard defines a, a value of 3.6 milliamps on the lower side. Anything that is lower than 3.6 is considered like a bad PV on the low side.
Oh,
That is disconnection or
right.
you can say low signal.
Right.
Anything above 21 milliamps is considered as a bad PV on the transmitter side. Could be due to some overload, failing field device, could be a failing input card, could be any of these.
Yeah, right.
And such things. So these things help you to identify or helps the engineer to identify is the problem, on the card side, on the field device, and also what do you do? How do you use this in the software to shut off things in the form of interlocks? In other words, let's say if I'm trying to measure the pressure of a boiler. Now, if my main pressure transmitter is supposed to show me a value between 4 and 20, suddenly it's showing me less than 3.6 milliamps.
Yeah,
Now, then the question is, I'm getting a value, but it's too low. Now, I cannot rely on that.
yeah. So there can be an interlock which will
Exactly
take corrective action on it to prevent subsequent damage.
Exactly.
Yeah, that's very interesting actually.